All right. This is going to be the first of two example angles of depression slash elevation problems. So I wanted to do a couple just so you guys can kind of see how I might choose to attack it. A few things that I like to do is first, I'm going to read the problem all the way through. I'm going to look for things that I might think are important, um, and then I'm going to draw a picture, and then we'll go from there. These elevation and depression problems, it is going to be remarkably useful to draw those pictures. A lot of the situations are tough to visualize unless you do take the time to draw it out. These aren't quick problems. They're going to take 5 to 10 minutes, and that's okay. And that's why I only gave you guys 4 of them. So I want you to take the time, draw the pictures, and then we can discuss where to go from there. But if you can draw the picture, then all it comes down to is just using some of the trig that we've been practicing. So let's start out with just reading the problem. So an observer in a lighthouse is 70 feet above the water. He sights 2 boats in the water directly in front of him. The angle of depression to the nearest boat is 48 degrees. The angle of depression from him to the other boat is 22 degrees. And we want to find what the distance is between the 2 boats. Right? So first thing is I'm just going to go through and underline some things that I think are important. One is I think that the lighthouse is, or the observer in the lighthouse, he's 70 feet above the water. Essentially, he's 70 feet up, so we want to underline that. That's going to be a useful piece of information. 2 boats in the water, and so we're going to probably have measurements for both of those, and we get that there's an angle of depression for one boat, and that's 48 degrees, and another angle of depression for the second boat, which is 22 degrees. Right? So I underlined angle of depression because it's important that we're using angle of depression, not angle of elevation. If we're using angle of elevation, then we've got some guy in a lighthouse and he's looking at a boat that's above him at 48 degrees. So it's important that we do use angle of depression, so we're getting down to the water and looking at it from that point. Right? And so our goal is to find the distance between the 2 boats. And so let's draw a picture and kind of see how we might go about that. So we've got a lighthouse, which we'll do in yellow. And here's my little guy. He's standing up here. It kind of looks like, okay, no. But it's a lighthouse. There's the light. So he's in a lighthouse. Maybe there's some rocks down here. And then we've got some water. Right? And so first thing we know is that the lighthouse, or at least the distance to the observer, is 70 feet. So that is 70 feet. Okay. Now the second thing I know is that there's 2 boats in the water, so we will do a green boat. And a red boat. And that's my best boat drawing skills. So let's start using the other pieces of data that we had. So the first thing we had was that the angle of depression to the nearest boat is 48 degrees. So just a reminder, so if I have, so we're going to build this triangle here. The angle of depression is if I take the line of sight from my observer down to the closer boat, which is the green boat. Okay. The angle of depression is that top angle there. So If you need some review on that, I would go back to the week 3, lesson 1 and 2, where that was covered in the notes portion. So we know that the angle of depression is here, and that's 48 degrees. And then the height hasn't changed. This line, since it's parallel to the water, is still 70 feet above the boat. So, not degrees, sorry, 70 feet. So that's our first triangle that we can draw. Second triangle that we can draw has an angle of depression of 22 degrees. So I'm going to draw that. And that angle is 22 degrees. And once again, this line is parallel, so the height doesn't change, still 70 feet, despite what my drawing may look like. Okay, so we've got two different triangles here. We know both elevations of depression, and we want to figure out what, let's see here. I want to figure out this distance here. Okay, so my proposition is that we find how far away horizontally both of the boats are. So what that means is that I'm finding this length here. Maybe I should have done that in red. This length here. And then I'm finding this length here. And then that'll give us, if we take the red distance and subtract the green distance, then we'll get out the distance between the two boats. Right? So I'm going to redraw both of those triangles just separately, so that we can start going about using trig. So the green triangle will be to the leftmost boat, and the red will be to the rightmost boat. So first triangle, 70 feet tall, angle of depression of 48 degrees, and we want to find the length of that. And then our second triangle, same height, 70 degrees, angle of depression 22 degrees, and we want to find this length here. Okay, so now we've turned it into essentially a trig problem. So if we completely get rid of everything else, we've just got two triangles, and we're trying to find a missing side length. So you'll recall, if we're going to find a missing side length, then the first thing that I want to do is figure out which angle I'm going to use, and then figure out what my sides are. So obviously I'm going to use that 48-degree angle, as that's the angle that I've been given. Then I want to label the sides. So 70 degrees is on, or 70 feet is on the opposite side of 48. So that's my opposite side. And x is not the hypotenuse, it's not the opposite, so x would be my adjacent side. And so if I recall SOHCAHTOA, I've got the opposite and the adjacent. So it's not sine because that's opposite and hypotenuse. It's not cosine because that's adjacent and hypotenuse, so it would have to be tangent. So I'm going to set up a tangent expression, and then we can try and solve, right? So I know that the tangent of 48 degrees is equal to the opposite over the adjacent, which is 70 over x. Well, if you'll recall, I want to solve for x, and so because my x is in the denominator, to solve for x, I can multiply both sides by x and then divide both sides by the tangent of 48, or essentially just my x and my tangent of 48 switch places, and so x is equal to 70 divided by the tangent of 48. right? So at this point, you may open up Desmos, make sure that you switch it to degree mode from radian. So if you go to the wrench in the right-hand corner and at the bottom, you'll select degrees, and then you're going to plug that in. So I'm taking 70 divided by the tangent of 48, and I get 63.03, and that's feet, right? So what that is that's our first distance here. So at least horizontally, if the boat was on the same level with the observer, it would be 63.03 feet away from the observer. Okay, so now we want to do the same thing. We want to find that second length, and then we can find the difference between the two, and that'll give us the difference between the two boats. So once again, I'm focusing in on the 22-degree angle, as that's the angle that I have, and it's exactly the same to the previous problem where 70 is the opposite and x is the adjacent. So once again, I'm going to use tangent. The only difference is that this time the angle measure is different at 22 degrees, equal to the opposite 70, the adjacent x, and just by looking at our pattern here and looking at the previous problem that we already solved, we can just reuse the work we did there, 70 over the tangent of 22, and we'll plug that into Desmos or your calculator depending on what you have. So 70 divided by, 70 divided by tangent of 22 is 173.26 feet. So now this red distance here is 173.26 feet. So now I got both distances, right? And so if I take the difference between those two distances, what I'll be left with is the distance between the two boats, which is the question that we were asked. So I want to take the longer distance, 173.26 feet. I'm going to subtract the shorter distance, 63.03 feet. And what I get out should be the distance between the two boats. So let's do that. And so we've got 110.23 feet. And then I would probably just round that to the nearest foot and say that our answer is that the distance between the two boats is 110 feet. Right? So just to recap, right off the bat, it's a word problem. It seems like a lot. I will grant you that this is a difficult problem, and it does take some practice to begin to break it down. But the key is to be able to distinguish between elevation of or angle of elevation and angle of depression, and then to be able to draw those pictures and get the proper triangles. Once you've got the triangles, it's basic trig stuff that we've been practicing, and hopefully most of us are getting pretty comfortable at. And then just making sure that we answer the question that's actually asked of us. So this is example 1. I'll also do an example of another example. I don't know if it'll be elevation or expression or depression, sorry. But if you have additional questions, please reach out. If you'd like more examples beyond these two, I can also do that. But hopefully this was helpful.